In October 2003, China put a human in space for the very first time. They were nearly 40 years behind the United States and Russia. By 2024, that cadence reached 68 orbital launches in a single year, supported by a permanently crewed outpost, the Tiangong space station. In 2024, the Tang'e 6 mission landed a probe on the far side of the moon and returned samples to Earth, a feat never before achieved in space exploration. Closing a 40-year technological gap in a domain as unforgiving as aerospace normally takes multiple generations. China is on track to fully execute its national space strategy by 2027. This hyper-accelerated timeline relies on a specific organizational model, a vertically integrated machine that fuses state planning, academic research, military operations, and commercial startups into a single coordinated engine. The engine begins with the human R&D talent pipeline. Beijing University operates as a state-directed engineering lab. Students build actual sounding rockets and microsatellites as part of their core engineering practice. This visualization tracks that talent pool. Over 65% of Beijing graduates move directly into national defense and aerospace positions. These engineers flow into massive state-owned enterprises, primarily the China Aerospace Science and Technology Corporation, or CASC. This is the industrial application of civil-military fusion. CASC acts as the muscle, converting academic research into standardized military and commercial hardware. Production targets are set at industrial levels. Under the Shanghai Action Plan, the city intends to manufacture 50 commercial rockets and 600 satellites every year by 2025. By linking the university labs directly to the assembly lines, the state removes the traditional friction between theoretical science and mass production. Scaling operations at this level requires massive staging grounds. The Wenchang Space Launch Site serves as the geographic anchor for China's heavy lift capabilities. Wenchang's 19-degree north latitude gives heavy payloads an equatorial rotational boost, while its deep-water seaport allows delivery of massive long-march rockets. In flight, they're managed by a global network of tracking, telemetry, and control ground stations, ensuring continuous communication to orbit. In 2014, the State Council pivoted, issuing a policy that opened the aerospace sector to private capital for the first time. This created a state-orchestrated startup ecosystem. These new commercial firms leverage the established supply chains and infrastructure of the state-owned giants. The goal is cultivating national champions, private companies matching Western agility while benefiting from state-level resources and low operational costs. This completes the ecosystem. China now controls an end-to-end machine, combining state funding with the speed of commercial industry. This entire integrated system provides China with an autonomous orbital architecture. The International Space Station is currently scheduled for deorbiting by 2030. In its wake, China's Tiangong station could stand as the only operational sovereign outpost in orbit. China is currently exporting these orbital capabilities through an initiative known as the Space Silk Road. This physical model shows the scale of that reach. It includes the 45-satellite Beidou navigation constellation and the Coalition for the International Lunar Research Station. By providing navigation and communication infrastructure to the global south, Beijing is building deep diplomatic and commercial dependencies that extend from the Earth into orbit. China has built its space program as a specialized industrial platform, engineered to restructure the global geopolitical balance of the 21st century.